The world of decentralized technology is dominated by two giants, Ethereum and Solana. Ethereum, the pioneer, brought smart contracts to the world and became the backbone of DeFi and NFTs, prized for its security and reliability. Solana, the high-speed challenger, burst onto the scene with lightning-fast transactions and ultra-low fees, targeting applications that demand scale and performance. These platforms represent two competing visions for the future of Web3. Ethereum's methodical security-first evolution versus Solana's aggressive, performance-driven innovation. As of 2025, their rivalry is shaping the next era of the internet. Which approach will define the digital landscape? Let's dive into their strengths, weaknesses, and what the future holds. Ethereum operates on a proof-of-stake consensus mechanism, where validators are required to lock up or stake their ETH in order to help secure the network. In return, these validators earn rewards for honest participation, but they also face penalties if they act maliciously or fail to perform their duties. This system is designed to encourage good behavior and maintain the integrity of the blockchain, making it more energy efficient than older proof-of-work systems. The threat of penalties ensures that validators are incentivized to act in the network's best interest, reducing the risk of attacks or disruptions. Solana, on the other hand, takes a different approach. It combines proof-of-stake with a unique innovation called proof-of-history, a cryptographic clock that timestamps every transaction. This allows the network to agree on the order of events without requiring constant back-and-forth communication between nodes, which is a major bottleneck in many blockchains. By using this built-in clock, Solana can process thousands of transactions per second, making it one of the fastest blockchains in the world. This speed is a direct result of its innovative architecture. When it comes to scaling, Ethereum is taking a modular approach. The network is being designed to split data and processing across many smaller shards, each of which can handle its own transactions and smart contracts. All of these shards ultimately settle on the main Ethereum chain, ensuring security and consistency. This modular design allows more people to participate in securing the network, increases its overall capacity, and makes it easier for new users and developers to get involved. Solana, by contrast, is monolithic. All activity happens on a single powerful chain, which is optimized for speed by leveraging the latest hardware and software advancements. This design choice enables high throughput, but requires more robust infrastructure. Ethereum's approach prioritizes decentralization and accessibility, aiming to make it possible for anyone, anywhere, to participate in the network without needing specialized equipment. Solana's design, meanwhile, is all about raw performance and seamless composability, allowing developers to build complex applications that interact instantly and efficiently. The result? Two radically different blueprints for scaling the next generation of the internet. One focused on inclusivity and decentralization, the other on speed and high performance. Each approach comes with its own set of trade-offs and advantages, shaping the future of blockchain technology in unique ways. Ethereum's ecosystem is mature and trusted, home to DeFi giants like MakerDAO, Uniswap, and Aave, and the birthplace of iconic NFT projects. Its users value security, decentralization, and high-value transactions. Solana, meanwhile, thrives in areas demanding speed and low costs, like decentralized infrastructure, Helium, rapid-fire NFT trading, payments, and Web3 gaming. Its community is younger, more consumer-focused, and drawn to the fast, affordable experience. Ethereum attracts long-term investors and developers who value robust infrastructure and philosophical ideals. Solana's developer culture is about rapid innovation and mainstream appeal. Each chain's user base reflects its core strengths and priorities. Solana's speed is truly unmatched in the blockchain world, capable of handling thousands of transactions per second with ease. This high throughput means that decentralized apps built on Solana can deliver a user experience that feels as smooth and responsive as traditional web services, making it ideal for everything from gaming to finance. Developers and users alike benefit from this lightning-fast performance, which helps drive innovation and adoption across a wide range of industries. In contrast, Ethereum's mainnet is significantly slower, often processing far fewer transactions per second. This can lead to network congestion, especially during periods of high demand, causing delays and sometimes frustrating user experiences. As a result, gas fees can spike dramatically, making it expensive to use Ethereum for everyday transactions or smaller payments. On Solana, transaction fees remain consistently low, typically just a fraction of a cent. This affordability enables microtransactions and encourages users to interact with apps more frequently, opening up new possibilities for creators and businesses to build engaging, cost-effective services. Ethereum's recent transition to a proof-of-stake consensus mechanism has been a game-changer for its environmental impact. This upgrade slashed its energy consumption by over 99%, making Ethereum one of the most energy-efficient blockchains available today and addressing one of its biggest criticisms from the past. Solana, on the other hand, was designed from the ground up with energy efficiency in mind. Each transaction on Solana uses less energy than a single Google search, making it a leader in sustainable blockchain technology and appealing to environmentally conscious users and developers. Thanks to these innovations, both Solana and Ethereum are now considered environmentally friendly, especially when compared to older proof-of-work blockchains like Bitcoin, which require massive amounts of energy to operate. As a result, the conversation in the blockchain community has shifted. Instead of focusing on energy consumption, the debate now centers on other important factors, such as decentralization, network security, and the long-term sustainability of each platform's approach. For everyday users and businesses, the choice between Solana and Ethereum often comes down to a trade-off. Do you prioritize speed and low costs, or do you value security and decentralization above all else? Each platform offers unique strengths, and the best choice depends on your specific needs and goals. What's clear is that both Solana and Ethereum have made major strides in sustainability, setting new standards for the blockchain industry and paving the way for a greener, more efficient digital future. Ethereum's 2025 roadmap is packed with ambitious upgrades, with danksharding taking center stage as the next major leap forward for the network. This innovative approach to data storage and transaction processing is designed to dramatically increase Ethereum's capacity, making it possible to handle far more transactions per second than ever before. By enabling Layer 2 solutions to process transactions much more cheaply and efficiently, danksharding will help reduce congestion and lower fees, making Ethereum more accessible to users and developers around the world. Another key upgrade, known as the Verge, will introduce Verkle trees, a new cryptographic structure that will streamline how data is stored and accessed on the blockchain. This will make it significantly easier for anyone to run a node, lowering hardware requirements and boosting decentralization by allowing more participants to help secure the network. Together, these upgrades are set to transform Ethereum into a highly scalable, deeply decentralized settlement layer that can support the next generation of Web3 applications and services. Meanwhile, Solana is charting its own path, focusing on optimizing its high-performance monolithic chain architecture to deliver even greater speed and efficiency. The upcoming FireDancer validator client, developed in collaboration with Jump Crypto, promises to dramatically increase throughput and resilience, making the network more robust against outages and attacks. By introducing multiple independent validator clients, Solana will reduce the risk of bugs or vulnerabilities affecting the entire network, enhancing both security and reliability. Solana's team is also working hard to improve network stability and develop a smarter, more dynamic fee market that can adapt to changing demand. This will allow users to pay for transaction priority during periods of high activity, ensuring a smoother experience for everyone, even when the network is busy. These improvements are absolutely critical for maintaining reliability and trust as Solana's user base and ecosystem continue to grow at a rapid pace. In 2025, both Ethereum and Solana are racing to overcome their biggest technical challenges, pushing the boundaries of blockchain technology and unlocking the next wave of global adoption for decentralized applications. Ethereum's developer community is its backbone, large, experienced, and research-driven. Solidity, its main language, has a vast ecosystem of tools and resources, making it accessible for new and veteran developers alike. Upgrades are slow and deliberate, with intense peer review to ensure security and long-term viability. This culture attracts builders focused on security, decentralization, and the long game. Solana's developer community is younger, energetic, and focused on user experience. Rust, Solana's primary language, is powerful but challenging, attracting developers who value performance. The community is fast-moving, collaborative, and pragmatic, with frequent hackathons and a ship-fast mentality. Solana's culture is about rapid iteration and onboarding millions of users. Both communities reflect their chain's philosophy, Ethereum for trust and security, Solana for speed and innovation. Ethereum's biggest challenge is achieving seamless scalability without sacrificing security or decentralization. Layer 2s help, but moving assets between them can be confusing and risky for users. High base layer fees could push some applications to cheaper chains, limiting Ethereum's reach. There are also concerns about centralization among staking providers. Solana's main challenge is network stability. Past outages have hurt confidence. Its high hardware requirements make it harder for average users to run validators, raising centralization concerns. Both chains face tough trade-offs as they scale. Ethereum risks complexity, Solana risks concentration. Many experts see Ethereum and Solana as complementary, not competitors, in a multi-chain world. Ethereum is viewed as the secure, global settlement layer for high-value assets. Solana is seen as the performance layer, ideal for fast, consumer-facing apps. Some predict users will store assets on Ethereum but use Solana for daily activities, with seamless interoperability. Others believe Ethereum's Layer 2s could reclaim lost ground if they match Solana's speed and cost. If Solana solves its stability issues, its simplicity and performance could keep it ahead in consumer markets. The future may depend less on one chain winning and more on how well they integrate. The lines between ecosystems are already starting to blur. The Ethereum versus Solana showdown is a clash of philosophies, security and decentralization versus speed and accessibility. Ethereum is the trusted foundation for DeFi, high-value NFTs, and institutional-grade applications. Solana is the go-to for fast, affordable, consumer-focused apps, games, payments, and NFTs that need scale. For developers and users, the choice depends on priorities: security and trust, or speed and cost. Ethereum's higher fees buy peace of mind for high-value assets. Solana's low fees and speed unlock new use cases and mainstream adoption. In 2025, both are likely to thrive, serving different but vital roles in the digital economy. The future of Web3 is not winner-take-all, it's a world where both titans shape the next internet.